If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.
Hi. Well, yes, it is. Hey, Lynzie.
Look it, I'm in a new spot. You can kind of see my PlastChicks 3D printed sign. You can't really. I didn't do a great job. We'll try again next time.
I mean, you can see PlastChicks.
Yeah, so you get it. You get the vibe. It's pink. Like, what else could it be saying?
Yeah, I'm pretty sure I know what it says.
Perfect.
Well, I'm Mercedes Landazuri.
And I'm Lynzie Nebel.
And with our powers combined, we are PlastChicks, the voices of resin.
And we are here to be so resonable with you today.
That's a new one.
I'm feeling fancy. I've had a full Diet Coke this afternoon.
This is one of the like, I don't know, one of the few times I feel like our chaos like meets, like, and I feel like that day might be today. Ooh. Like, you know, your level is pretty high today.
It's pretty chaotic.
Almost like a Mercedes level.
So this could be our best or worst episode through no fault of our guests. It's all just based on whether we take it or not. Everybody come listen. We do wonderful work. But you can listen to this podcast the first Friday of every month. You can listen to it on YouTube and watch it because YouTube has a visual component to it for those of you unfamiliar with YouTube. You can't find us on TikTok, and that has nothing to do with the band. It has everything to do with us not getting ourselves together.
Well, there are just so many things and so many logins and so many platforms.
Yeah.
Yeah. I mean, we record in landscape. TikTok is, you know, the other one.
it's too much in our advanced stages to try and fight against the power. So YouTube and all your podcast platforms, and that's where you can find us. And that's a good amount of places to find us.
Yeah. Or if you're at a trade show or something like that, you can also sometimes find us in the women's bathroom. It's usually empty at these things except for us.
Yeah. And we probably will have snacks, not in the bathroom, but
not in the bathroom. We'll probably come out and get snacks with you at some point. Yeah. Maybe walk the show a little bit.
You know, if that happens, so be it.
What are we talking about?
We're so in the chaos lane.
We haven't even introduced our guests, and I'm already talking about our bathroom meetups at trade shows.
It might set a new record.
I wanted to join in when you were talking about the snacks.
You can meet us in the bathroom. We will have snacks.
Yeah. Maybe the snacks will be covered in a plastic wrapper.
Yes, highly likely.
And they will. Look at us go. So today we have our actually second sibling episode.
That's true, yeah.
So we have formally interviewed the Hoffers of Hoffer Plastics, and now we have the Kenders. Not of Kender Plastics, but maybe one day.
Yeah, maybe
one day. So I will introduce my fellow injection molding board member, Laura Kender. She's a Polymer Process Engineer at Corning Life Sciences. Welcome, Laura.
Yes, thanks for having us.
And then we have Elizabeth Kender, who is a Senior Product Developer at New Balance.
Hi, I'm so excited to be here with you guys.
Thanks, Elizabeth.
And last but not least, with the better setup than all of us for this podcast, it's Stephen Kender, the Senior Design Engineer at UPPAbaby.
I tend to over-prepare, but thank you for having me.
And for those of you who are just listening, well, you might be able to hear it, but Stephen is decked out with, I think he said a new camera, but then also an actual like microphone. It looks very official.
It's so official.
Some pretty baller headphones as well. He looks like a true podcaster.
Yeah.
I think he's coming for our job, Lynzie.
Probably. Do you know how to be a Plast chick? Is the first question.
Plast guys doesn't really work as well. Plast dudes.
And that's why we took the copyright.
So thank you so much, everyone, for joining us. You all started out studying plastics engineering at UMass Lowell. Is that correct?
Yes, UMass Lowell.
Mm-hmm.
Yeah. Now, how did your experiences in the program shape your career paths, and what surprised you the most about the versatility of a plastics degree?
I'll defer to you, Lauren Elizabeth, because you guys were the ones who roped me into plastics
Yeah.
my freshman year. So you guys can start with how you got into it.
Yeah,
Elizabeth and I both wanted to do engineering. We actually both wanted to go into the sporting good field, so designing like hockey helmets or lacrosse sticks. So we actually decided pretty much last minute to go to UMass Lowell. We grew up in Chelmsford, Mass. And so we weren't really considering going to UMass Lowell since it was so close to home. But we couldn't decide where we wanted to go. So our mom was like, why don't you just go tour UMass Lowell one more time? And so we went and we were just walking through the halls of the different engineering departments, and we ran into the chairman at the time. It was Robert Malloy.
Oh,
And he,
love him.
oh, do you know? Yeah, isn't he the best?
he's the best.
He is.
I miss
And
him.
he completely sold us on the program. He showed us all the labs. And so that's how we decided to go to UMass Lowell and do plastics. Alyssa, do you want to talk about how doing the program really helped shape our careers, and then how Stephen got involved?
Yeah, we were in the time that we were walking through the halls, and he was showing us all the molds and the machines. We just got so excited. And he also talked about there was a wall of all these alumni that had graduated from the program. And one of the guys on the wall, his job was at the time creating and developing and designing hockey helmets for the NHL. So when Laura and I saw that, we were like, oh my gosh, we grew up playing hockey, we played lacrosse. This would be a dream to be able to do something with the plastics engineering degree. So that also sold us.
Nice.
So I know he really shaped our decision into going. And so we loved the first year. We were learning so much. And Stephen came in the year after that. And I think you were mechanical, right, Stephen? Yeah.
Yeah.
And I think he saw how much we were learning, how much fun we were having, how much networking we were doing with all these professors and the fellow students. And we were like, you have to do this. So it was probably within months that he switched his degree to plastics. And it was actually cool. We were able to do safety lecture together every Tuesday. We were in the same class. And I think, Stephen, it was probably the best decision to switch to plastics.
Yeah. We were at an event, and you guys were talking with Professor Malloy, and roped me into it, and the three of you just were like ganging up on me, like, why are you a mechanical engineer? Why not join plastics? Because I initially went as a mechie and then a biomedical minor, and I was thinking similar path as Lauren Elizabeth, where like, I don't know if you've ever seen I don't know if it still exists, but the show Sports Science on ESPN. It was just like interesting stuff where they put a bunch of sensors on athletes and just try and see how their muscles work and how they perform in like crazy environments. And that was like right down my alley. I wanted to do something in kinesiology or something like that. And the plastics head, Professor Malloy, was like, we have like a medical device design path, and we have part design and mold design. You could do all that, and we do everything everything important that mechanical engineers learn, like statics and dynamics, and then you get everything chemistry and fluid dynamics. You get like everything bundled into one degree, where you become pretty well rounded. And I really took to the part design and the mold design. But yeah, that one day of Professor Malloy and the twins just being like, hey, why are you a mechanical engineer?
They really
doing
came
plastics?
for you. There is no pressure,
worked.
like a sibling pressure.
Menacing is what it sounds like. Very menacing.
But like menacing in the best way.
And it was the best having each other. Yeah. It was
And
the
I
best
remember seeing things. Yeah, and I remember seeing designs that you made, Stephen, part designs in cases on the walls that they showed. You did so well.
That was one of the cool things, was that I'm sure we'll talk about this soon, but they had a part design class where they had cases in the hallway of parts that people had made, like in college, like going through the entire design process and molding it. And I was just like, wow, we have all these machines here. Like, it's amazing.
I think that's one of the things that gets missed when you talk about plastics engineering as like a degree to someone who has no familiarity, is like the actual, like, you can see things go from like the thought to the actual in your hand product. And like, let's be honest, that makes it so much cooler.
Yeah.
Like,
It's more than just a
Absolutely.
textbook learning about the chemistry of a polymer. You're actually learning about the process on how to make plastic parts.
yeah, I know at Penn State, I will let that sink in. You know,
His rivals.
Like
the lab we had was like downstairs. I had these big beautiful windows, and it like the cafe was like right next to it, so you could see in. And I remember people would always be like, what are you guys doing in there? And it's like, yeah, we're doing the cool stuff, you guys are doing the boring stuff, go back to your notebooks. It's so much better. I mean, I think we can all agree.
Yeah.
You know, so as siblings, you know, you guys are all in the same degree, same profession. Like, none of you kind of really broke off into something weird after, because I know sometimes people go in those weird directions after after they graduate. But can you share, like, besides the menacing pressure to join plastics, have there ever been any other like memorable experiences or times where like you guys teamed up to like learn from each other or work on projects to each other? You know, and is it cool to be able to bounce some of these, like, to nerd out with people that like get it? Because I tell my husband stuff all the time, and he's like, okay, great. And I'm like, come on, this is cool.
She just texts me.
Yeah, I do. I usually text Mercedes.
That's the
really
best
is
part
the-
though. Like, if I ever have questions, I go to Laura and Stephen about anything plastics or polymers.
Yeah, Stephen is the polymer guru. So anytime I have a question about the chemistry or the polymers, I'm texting Stephen.
I disavow that name. I don't want to be known as the polymer guru.
Well, I
Everyone's
think
gonna be
that's
hitting you
your
up soon.
podcast name.
I was gonna say, there's your podcast.
But something, I'm sorry.
No, just of all the things throughout plastics engineering degree, polymer science was the thing that stuck least in my brain. Just a
Something
lot
that
of micro stuff.
something to go back to the first part of the question was about like siblings being all together. The UMass Lowell had a difference maker program that we all loved, and it was so helpful because you were able to come up with an idea, and there were advisors and mentors that helped you create that idea and do some of the business side and talk about how you would bring that idea to life. And so us three created a team, and for multiple years in a row, we just developed ideas and pretended like we were making product, and learned so much together as being the triplets in plastics.
We came close to actually making a product. It was
We did, and we won
yeah.
some money too.
Yeah, it was like an innovation program,
Yeah.
and it kind of linked all of our like interest in sports related like careers, where we took like a non-Newtonian fluid and embedded it into some fabrics and demonstrated how it can help with impact force reduction, and like wanted to use it for like athletic equipment. We did a bunch of presentations. We all wore like nice clothes.
Which are hard to come by in college.
So that could definitely
learn public speaking.
Yeah, we did public speaking. We won money.
Yeah.
We applied for a patent.
That's amazing. What an incredible experience. And to be able to do that with family too, before you even graduate, that's incredible. What an opportunity.
And like the ability to ask someone that like, you know, you've seen them do the dumbest stuff you've ever seen. So like to be able to be like, here's a dumb question, but I know you can't judge me.
Yes, exactly.
You still have to love me after this terrible idea I'm about to tell you.
Takes these backsies.
So you all have such diverse roles within our industry, right? Laura, you're in life science, Elizabeth in footwear and apparel, or mainly footwear? Or...
Footwear. My
Footwear.
company does both, but New Balance,
Yeah.
but I'm on the footwear side.
And then Stephen, baby gear. So could you each share a little bit about your current roles and how you found your unique path in the industry thus far?
Yeah, I guess since I'm the oldest, I'm oldest by 7 minutes.
I was just gonna
Elizabeth
say
is-
that.
I can go first. Actually, I didn't realize how many things in the universe are made out of plastic until I actually studied plastics engineering. Even just clothing, how nylon is considered it's a polymer, it's a plastic. So you really can do so much with plastics. I actually started out at I entered at New Balance in college. I also interned at a company called Amphenol TCS. They made computer connectors and iPhone connectors, so the whole body of the part was made out of plastic. But I really liked my internship and the athletic side of things at New Balance. And so I kind of continued on with that after college. I moved over to Converse and did the footwear there. And then after being there for 5 years, I ended up wanting to get back and do more hands-on work and actually stand by an injection molding machine and learn more about the processing side. So I moved over to Corning Life Sciences and I'm absolutely loving it. It's a dream job. But the path goes to show how much you can do with plastics. And so currently right now we make plastic products that scientists use in the lab, anywhere from drug discovery and vaccine work all the way up to bioproduction. And I'm specifically in the plant in Kennebunk, Maine. So it's also nice to be in Maine. I've been loving this job. Elizabeth, do you want to go?
You've been there for more than 2 years too, right?
What did you say?
You've been more there for longer than 2 years, right?
Yeah, it'll be 3 years this year.
That's awesome. Yeah, but so I've stayed in the footwear industry. I'm currently been at New Balance for 9 years this May, it was my first job out of college and I absolutely love it. But I got into it because senior year in the Tuesday plastic safety lecture that I spoke about earlier about us three all being in it, the research and development director at New Balance spoke in one of the classes and
Who I think I was it Dan Dempsey?
oh, Dan Dempsey, I worked with him my first year in New Balance, but it wasn't him.
I graduated with him, so that's why.
Well, yeah, he's awesome. He
Little
taught me
plastic
how
bro.
to, yeah, he taught me how to 3D print at New Balance.
He's a
But he was
commercially
actually
lovely person.
he's still there too. It was actually Jim Connors who spoke, and everything he talked about, I was just thought I could see myself doing something at New Balance. And so Laura and I connected with him after class, and we just stayed in touch with him, and we ended up hearing that there were internships open. So this was in 2016 when we graduated. And we were also doing our master's at UMass Lowell. They had a +1 program, so we stayed the extra year to do our master's in plastics engineering. And so during that year, we both interned at New Balance. And that's where the footwear journey started. So I started on the innovation team, and my boss I was fortunate to have a position open on that team. So I stayed for a year, and it was a footwear and engineering training position. So I learned a ton of background information on designing and developing footwear. And then Laura and I both played Division I lacrosse at UMass Lowell, so they had an opening on the lacrosse team at New Balance to develop lacrosse shoes. And that was a dream to do. So I did lacrosse footwear for I don't know how many years, but a few years. And it was awesome working with lacrosse athletes and using the background of the sport that I had to create footwear that athletes were wearing every day. And then I transitioned. I've been on the basketball team for a few years now. So I develop all of the basketball shoes, and I absolutely love it because so many kids love basketball and I get to see my shoes on TV, and that's really rewarding to see. But it's also just being able to work with athletes every day. We have 4 rounds of prototypes every shoe. We start 2 years in advance and we go through 4 rounds of prototypes, and each round we wear test with athletes around the country and local colleges and our professional athletes for 4 weeks. And then we'll use the feedback for fit, durability, and each round improve the shoes. So we're working with athletes every day, and it's really fun.
That's pretty awesome.
Drop the mic.
Okay, we found a very cool job.
And you can tell she's very passionate about it too.
I love New Balance.
How I got into the juvenile products industry at I guess far less interesting. It wasn't part of like a network. I was senior year of college. I was just looking on job boards. UMass Lowell had one through their co-op program, and I was just looking for stuff, and I went into LinkedIn and saw a design engineer job at UPPAbaby, and I'd never really applied for a job on LinkedIn, so I hit apply, and I was expecting a website to pop up and enter my resume or my details, and all I got was a pop-up that was, "Thank you, your profile has been sent to,
Hope your
to the
LinkedIn was
recruiter."
good.
All I said was like, "Well, I'm not getting that job." And then a couple weeks later, they were like, "Hey, we'll do you want to interview?" And that was 7 years ago, and I love working there. It's fantastic. It's just a perfect mix of using it's kind of like at an intersection of the automotive industry and consumer products, where you're using commodity plastics that the automotive industry uses and engineering plastics, but you're also adding a bunch of design elements to make it appealing to everyone, like anyone just walking through a store, like for their newborn, being like, "Oh wow, that looks good, I really want that." Like having to blend that and get engineering performance out of it, it's fantastic to do that every day.
Very cool. So not at all related to you being the baby of the family, or at least the baby of the Kender triplets, as they call
Yes,
them.
I am by 11 months not the baby of the family. and he zagged while we all zigged. He's doing actuarial sciences now.
Do you guys rub it in his face how cool your jobs are when you see him? Because
All the
I
time.
would.
He's in the money field, so he's
Beach money. It's all about the fun stuff. As somebody who's clearly on the fun side and not the money side.
For a while, when I was at Converse, Elizabeth, I don't know if you got these texts too, but Nicholas, our younger brother, would sometimes text ideas about footwear. So I think he was jealous a little.
Oh yeah. Oh, he's definitely jealous. He's definitely jealous.
I'd be jealous. And I liked Elizabeth, what I think you said about, it was really just like staying, or staying in touch with people you have seen, and I know that a lot of those safety lectures are part of like the local SPE chapter, or they kind of try and combine them. I was a Massachusetts site for a hot minute. I don't think that's the proper term, but that's okay. And like, I think sometimes people think, okay, yeah, it's good to be connected to other people and we should really like keep in touch, but that's what LinkedIn's for. But when you meet someone in person and you're able to like maintain that relationship, that's the stuff that like drives these cool job opportunities. I mean, sometimes you luck out and you apply on LinkedIn and your LinkedIn profile is apparently very wonderful immediately. But sometimes it's not. And sometimes it's about somebody knowing that there's a position open or knowing you personally over not knowing you. That I think it's underestimated sometimes. That's my soapbox for today.
Yeah, no, absolutely. I agree with you. Go ahead, Stephen.
No, I just remembered. I did leverage a part of the network.
See?
The hiring manager was a UMass Lowell graduate. So
See?
he got
There
his
we go.
master's degree there. Yeah.
It's all about that networking, then. My point, even more solidified.
That's
Thanks.
something I tell people to this day, like people looking for jobs in college, that networking is so key. I feel like having a great network behind you, and just you never know who they know. And I'm actually doing my MBA right now, New Balance. I know, I'm so excited. I finished in May. I've been doing it it's going to be almost a 2-year program, but so I'll have my MBA in May. But something I've been learning in the classes is that not only is your network important, like you could have 8 years of people that you've gained in your network, but it's also staying in contact with them, such as like if you see an article that reminds them of you, even if you haven't talked to them in a year, like send it to them so that you reconnect again, so that you do have that contact in the future.
Oh, you're like a modern day Glenn Beal. That's what he does. He's always sending letters to his
I was gonna say,
contacts.
but his are actual letters.
Yeah.
Handwritten.
Less emails or shares.
That's why I said modern day. That's why I said
This
modern
is
day.
modern day, yeah. Yeah, I think that's, that just really serves you well, like long into even talking to people that are retired. They're still like, who do I know?
Yeah.
And to build that network now, it's just smart.
And now we're in each other's network.
See,
Yeah.
now
Thanks to
we're-
SPE.
Yes, we are an SPE network growing strong. Now I'm gonna
Love
push you guys out. We're gonna find you guys in the bathroom. Not you, Stephen.
Yeah.
Sorry. We'll share snacks. It's gonna be great. See, now I'm all on the what kind of snacks can we bring into the bathroom in tech? Important priorities.
Jesus.
Yes.
A good one. Yeah.
So, you guys are all kind of working on different things, and I'm going to jump forward a little bit in our agenda because I know we're probably just going to tangent talk quite a bit for the rest of this episode.
That's kind of
It's the chaos
mood.
episode.
Fair to
Yeah, it's the chaos episode. So we're leaning into it. So you guys are all working on different things, but what are some of maybe the like industry-wide, we'll go injection molding because that's near and dear to my heart. Like stuff that's coming up that you think is cool, new developments, things that are maybe influencing your projects in ways you didn't think would maybe come into play.
For the injection molding side, I've been trying to really research AI and machine learning, and I've really been seeing how beneficial that can be for the injection molding process. Even just teaching a machine the data that you've been collecting for years, putting it into a computer, having the machine learn that data and then be able to help you with the process, give you feedback right away, know what to change in the process. So that's definitely something I'm going to keep my eye on because that is going to be an industry driver, I feel like, in the future. And then polymer side, it's crazy how every year I feel like there's, whether it's from MIT or some research company, how polymers just keep getting stronger and stronger. Like now there's plastics as strong as steel. And so I'm just curious in the future what the polymers are going to look like and how strong they can get.
There could be a material that cuts through a boat, Mercedes.
Oh, that was from the show that I was watching that I texted Lynzie about.
A very 80s vibe kind of show.
It's a show called Three Body Problem, and I got super excited because there's this woman who's developing this really high-tech fiber, and then you finally see them making it, and I swear they like used an old extruder from like a master batch plant or something, like just because I see those all the time in our plants, right? And it's just like all painted brown. It's like out in the open. And then like 2 seconds later, they're cutting like a battleship open, like with this fiber. I'm like, okay. Not yet.
Science.
Yeah. I do have to say that, like, if I did an internship with just like molding for like a medical device company in my like junior year, and if we had like a machine learning algorithm to figure out process control limits, I would have liked that internship a lot better. Putting that all that data together was just not fun for me. Not fun for 20-year-old me.
And what about you, Elizabeth? What excites you the most?
I think the sustainability part of everything plastics, for a lot of everything that I know it's been years of this, but just so much focus on sustainability and how much recycled content we can use in our foams and our rubbers.
something being in the industry for years is pretty much the status quo for the plastics industry. You really gotta move it along very carefully.
Yeah.
But it's good as long as it's still being talked about. That is a positive, at least in my mind.
Yeah, some people get afraid by the word plastic,
Mhm.
but it's really like even biopolymers are a plastic. So we don't have to be afraid of the word plastic. We just need to think of better ways to be sustainable. Even we've been trying to figure out ways to be more sustainable on the actual process side of the injection molding, like how to use less energy and be more efficient. So that's another aspect of the sustainability too.
And what has been some of the most challenging projects that you all have gotten to work on in your careers so far?
Laura, you're oldest. Go ahead.
One thing that I love about the different paths I've gone, and especially at Corning, is every day there's a new problem. So I think that I can't really think of the most complex or complicated problem. I think that this might be a theoretical thing, but the biggest project I've worked on is basically like myself and where I want to be. So the hardest thing I went through was definitely choosing to leave Converse and go over to Corning, and just like taking that next leap of faith that this is what I want to do. I want to be back in science. So I think that's like the biggest project I've worked on.
That's such a self-aware
No, that's
answer,
so good.
though.
I know.
It's amazing.
I think for me, the most challenging thing was learning how to communicate. We work with Vietnam and Asia teams. So learning the different language, no, I don't know Vietnamese, but learning the different like language barriers, and they're 12 to 13 hours ahead of us. So being able to be flexible, get up early, talk to them while their day's still going on, or stay up later and talk to them. So that balance of doing that. But that's what excites me about the job too, being able to work with people around the world and being able to go to Vietnam and see all the molds and and everything they use there is eye-opening. So it's challenging, but it's after being there for 8 years now, it's just second nature to me.
Okay, cool. And how about you, Stephen?
So it's kind of twofold, I guess, where juvenile products industry, I guess for like most car seats in general, the industry has just kind of been, it kind of uses a lot of legacy technology where molds are pretty simple in design. They're huge parts, so they're by nature complex, but simple in overall design. There's not a lot of overmolding. There's not a lot of extra stuff going on up until the last few years. And my company wanted to make, and to brag, I guess, to shout out, make the lightest car seat on the market.
Which is a huge thing, because babies do be getting fat, and you put them in a heavy car seat and you are losing some.
Yeah, or if you have to carry four car seats.
Right.
I've never had to carry 4 car seats.
It does
My
add
mom
up
had
very
to do that.
fast.
See?
And so we were like, okay, like how do we do this with we're going to have to push boundaries a little bit. We're going to have to reduce wall thickness on a part that's like this big. And we got it down to 1.7 millimeter. Seeing the short shot analysis of that was amazing. Being able to, like, I think it was our first valve gated part. Designing that was like, whoa, we can do this. We can fill parts like this. Like it was just fun to go through that exercise, and then just taking foam and strategically placing it where it can actually act as a structural member, and replacing plastic with foam and lightweighting everything. Like you're trying to take a commodity plastic and both extracting every ounce of performance out of it and every ounce of weight out of it. And we're using just polypropylene. It's amazing what you can do with it now.
It's funny because you said in the beginning, like, oh, we're kind of using automotive technology. And I was like, oh yeah, I guess, because like you put the car seat in the car, that makes sense. And then I'm like, now, but it's like, no, like you are doing the same
Yeah.
thing the
Yeah.
automotive industry is doing.
That was those were finally like coming together for me too. I was like, oh yes, exactly.
Cars go through crash tests. Car
Right.
seats go through crash tests. We take that's a far larger market segment of the plastics industry, like automotive. So we have resins that we know they use, so and those work well, so we use those. We're even expanding to use other ones like this. I don't know if you've heard polyketone. That's like making a big push into the market now because there's trademarks and everything. Companies went out of business and now they're making a big push again. We're trying that out with everything because it's such a flexible polymer. Like you can change it to match properties of everything, and it's a good replacement for polyacetal, for nylon, sometimes even polypropylene in cases where we need a little bit more rigidity. So it's fun to be able to break those legacy technology bonds and move to the future. Like maybe if we're bold enough, we'll do like in mold labeling or something like that, which has been around forever, but it's
Don't get wild.
Yeah.
Well, really, the true test of a good car seat is can baby be sitting in it and another toddler flip it over and the baby stay in? That's the key.
Now we're
Speaking
looking
from
at-
experience.
Well,
Maybe,
Yeah.
maybe not. I don't know if I want to admit it on this podcast, so I'm just gonna go with a strong baby.
Anybody who sees your four boys together knows that you're speaking from experience.
It's 100% happening. It is all Fight Club all the time. Yeah, I mean, I think a lot of those, those are things. I love that you guys are speaking both from like the practical end of things, but also from like the like internal. Hi, I'm like a young professional in this industry. Like these are the things I want to like learn or grow or figure out about myself before I like start to. I mean, the way I always thought about it is like, it's casual dating until you settle down on a company you like, because sometimes you get bad advice and you go to a company and you're like, this isn't what I like. Or sometimes you really like it and you're like, but is this where I want to stay without knowing anything else about the industry or how people do things or what other technologies are out there? So I applaud all of you for those journeys. So we all very clearly love plastics, and I am just going to assume you all love plastics. This is a love with a capital L.
It's pretty clear. It's pretty
heart
evident.
0, underlined, all the things. What is your favorite part about injection molding? And please do not hold back.
Lynzie just really wanted to ask this
I did
one.
want to ask that one.
I love this question. I definitely won't say I don't like the screw of the injection molding, because if you have to ever pull those and clean it, it's a process.
Goodbye to your day. Goodbye to your week.
Yeah. I think I love just being able to see how complex a mold can be and how you can take a plastic and make such micro features or small parts. I think if I were to pick my favorite part of the machine, I would definitely say the knockout rods, because if you didn't have those, you wouldn't be able to get a part even out of the mold. So that's my favorite.
Answers. I love it.
Knockout rods, a good one. Yeah.
Elizabeth, do you have a favorite part? Or I mean, you don't have to go injection molding. You could just do your favorite part of plastics, I suppose.
Well, maybe before the injection molding is just the designing of the part and the CAD of it and making sure that it follows the guidelines for the injection molding machine and making sure that there won't be any issues while doing that. And then just the creativity of, you can make so much with an injection molding machine.
Yeah, and I think you're right, because some of these design people, Mercedes, look away.
I was waiting for somebody to say like, all of the colors. All the colors.
Not go with colors. Go with injection molding. It's amazing. But sometimes when you have people designing and they don't have that injection molding background, like it's easy for them to be led astray as to what features or what possibilities they can have. So I think, as much as I do love just being in front of a press, I do love the smell of polypropylene. Like, call me crazy, but it just smells so good.
I like acrylic. I personally like molding acrylic. I like that smell.
Oh,
Acrylic is a good second.
I couldn't stand acrylic, but yeah,
Really?
polypropylene.
Wait, that's so funny. We get shoes in the office, and sometimes people are like, "These smell disgusting." And I'm like, "I love it. I love this."
So good. So good.
And
Yeah.
Stephen, sorry, Lynzie, you were gonna say something?
No, I was gonna ask Stephen as well.
Yeah.
About the process, I guess two of my favorite parts are corny and be like, oh, I don't have a favorite. It's also good. But I do really like getting short shot analyses from the factory for big parts where you can see like, okay, we designed this giant part and like you can see how all the ribs are filling, and it's just super cool to like have those. I want to take one and just have like on my wall, just like one of that particular car seat shell that was 1.7 millimeter, like just have it all 5, 10, 25 on my wall.
That's great artwork, really.
It is really cool.
And there's a story behind it too.
And that stuff I also want to like send to professors at UMass Lowell for like plastic safety lecture, because the professor there, he loves to show like products that alumni have made and like some stuff that's real engineering challenges. But my other favorite part is texture, because we get
underrated
when we do engineering pilots. We get these parts that are just mold like like regular finish, and we're a very design centric company, so they always look terrible just because they're so shiny. You see the marks. It's very helpful to like check the molding of it because you can see the flow lines and everything, but they look so bad. And then texture comes and it's like a whole new thing, and it just looks so refined and nice.
So what you're saying is you love disguising.
Yeah.
And there's so much that you can do with it now. I mean, like the nano laser engraving that they're doing, you know, and the variation in textures you can have, like in
and you can do texture on foams now too, to like make it. You basically mask all the beading of like a foamed like EPP. It's something that I definitely want to look into for car seats. It would be awesome to have the lightweightness and flexibility of foam without having that ugly beaded texture on the outside.
Yeah.
Great answers. So we're almost out of time, but one last question for all three of you, or maybe combined. I don't know how you want to go about answering this, but how do you see the field of plastics engineering evolving in the next 5 to 10 years? And how do you hope to contribute to that in the future? And are there any aspirations for the three of you to work together in the future?
Yeah. Will you be the future Hoffers is what we need to know.
I think this is manifesting right now that we're going to be. And I don't know if anyone's watching, but my camera turned pink.
Yeah, you went pink.
That was a PlastChicks.
Are you in California? Are you in Southern California right now? Did they just stop fire retardant?
I wanted to be PlastChicks pink.
That's what I thought. I'm all for it.
I love it.
Oh no!
Oh no! Now we can't hear you.
Oh no!
Oh no! We can hear you.
We can hear you again.
We can hear you.
I don't know what happened. I have no idea how to make it not pink, but we'll just stick with it. I guess since I'm talking, I can answer. I can be the first to answer. Probably tying back to what Elizabeth said about sustainability and how the industry. I'm excited to see where we'll be in 10 years, because I know that there's a lot of regulations in Europe right now when it comes to plastics, and that's going to come over here into the United States eventually. So I'm excited to see how the industry shapes itself and to be more sustainable, and see all the new biopolymers that are being worked on come to life.
And then I think for me in the next 5 years, relating more back to the athlete side, but the whole shoe is made out of plastic. And I think about how every race or every Olympics, people are getting new records in every single year. And so how fast or how how far are these records going to go? And it starts with the footwear they're wearing. And
Mhm.
so, well, at least for the sports that are wearing sneakers, not like ice hockey or something, but like creating a shoe that will help these records keep getting broken year after year after year. And what goes into that.
I love that.
Fire, flames that would just lift you up. Speed.
And then for car seats, they're a performance product. So I've looked into how we can be more sustainable about the whole process, and because they're a, like, you have to survive crash testing. You can't really depend on regrind. We don't use any regrind, but it's very interesting, all these new lines of plastics that use pyrolysis for reclamation that basically keep the same properties. Would definitely need to go through a lot of testing to ensure that they do actually retain those properties. But I see that as something that could be really refined over the next 5 to 10 years, like real plastics recycling that is truly regenerative and renewable, and actually you get the same performance plastic out of it. And just, Laura alluded to it earlier, where companies are coming out with new grades of plastics that basically replace those old grades that can be molded thinner, can be molded lighter, so while keeping the same properties of your 3 millimeter wall thickness part, and you can mold them at like 1.5 or 2. And the industry is hurtling towards, we want lightweight, so we're going to figure out ways to make that happen. And I think that would just be such a fun thing to do, is just use these new plastics, push the boundaries with our mold design, and figure out how to use foams, different like high engineering resins, and just try and make the coolest, lightest products we can.
But the important
That
question
was a good
is,
answer.
are you guys going to start a company together? Are you gonna take the old engineering project and turn it into a real job?
Revive it.
Yes, we
Correct
need
me if
to.
I'm wrong, but I mean, it seems like they all have their dream jobs right now. I mean, all three of you
I
are
know.
so passionate about
Unfortunately.
the work you do. Unfortunately,
That gets right in your way.
5 or 10 years is a long time. We don't know where we could be, but yeah, maybe we do end up reviving that.
And we have an actuary. We have Nicholas who can help us with
You guys
numbers
are pretty
and
much
everything.
set to start
Yeah.
now.
then
Yeah.
then Nicholas is your other sibling's name, is that right?
Yeah.
Then Nicholas can finally be in the cool kids club,
Yeah.
right? Working
And
for a
our-
plastics company.
Our dad is director of IT, so he can do IT. Our mom is all things bio, so she'll help with the science stuff too.
I
We
mean,
can
this
create a
feels like
whole
a done
company.
deal.
Full
I
family.
don't think you get better setups than that. Well, guys, it's been really great talking to you. I love seeing 3 like young, dedicated, professionals coming in here. I'm gonna swear, kicking ass. Like,
Yeah.
I don't normally give the warning, but I gave it. I was feeling kind. I think you guys are awesome, and I really hope to see some of you in the bathroom in the future, just for snack purposes. And I really thank you guys for coming on today.
Yeah, absolutely. I mean, maybe it's a Kender thing that you guys are all so passionate about what you do, but I mean, it's always a treat, regardless of whether someone works in plastics or not. We do have a preference of talking to people who
We
work
do.
in plastics, but it's amazing to talk to people who really love what they do so much, and it's just so evident how excited you are about your work, how passionate you are about your work, and it's very inspiring. So keep doing what you're doing, and we're excited to see if there's a Kender Plastics in the future.
Thank you
do
so
have to
Thanks for
say,
having us. This was so fun.
It really was so fun. But Laura and Elizabeth are the most bubbly people you'll ever meet. They're genuinely excited about everything. And they're so fun.
We're very
to be around. So
excited.
it does rub off on you.